Hey there. Today we're going to try some practice with Pythagorean theorem and see what types of problems we could solve for it at a more basic level. But before I show you the types of problems, I wanted to talk a little bit about Pythagorean triples first. If you want to take a screenshot of this picture, I think it's a really great tool and it'll be a helpful resource. The basic idea behind Pythagorean triples is that these are numbers that always work out. They always create a right triangle together because they satisfy a squared plus b squared equals c squared. I like putting that c squared at the end, but it doesn't really matter. The single most common set of triples that you will see is this lovely triangle right here that I'm going to color in an orange. The 3, 4, 5 triangle, and that's how we would refer to it. It's a 3, 4, 5 triangle. If we know that the legs are 3 and 4, we don't even have to do the math if we know this triangle exists. The last side has to be 5. It works out with the Pythagorean theorem, 3 squared plus 4 squared. When you solve that, you end up getting 25, which is 5 squared. So if you were to solve a problem like this, you would get 5. But the point of the Pythagorean triple is that it's just such a common example that most people have it memorized. So if they had 3, 4, and x for the hypotenuse, you could just say that the answer was 5 without doing any work because you know the triple. If you don't know the triple, you got to do the work, and that's fine. It works the other way too. So if we know that the hypotenuse is 5 and one of the legs is 4, we don't even have to think about it. We know that 3 is the missing number there. And that's only if you know the triple. You could just put in that as the answer. You don't have to show any work, and you are done with that problem. This also works for triangles that have a proportion of 3, 4, and 5. So the way you might use that is, let's say that you know that the two legs are 6 and 8. Well, 6 is 3 times 2. 8 is 4 times 2. Therefore, we can assume the hypotenuse must be 10 because that's 5 times 2, and you wouldn't have to do any other work. So it works for multiples of all these numbers as well. Some other common triples would be 5, 12, 13. That goes with this picture. So you might see multiples of that. You might see 10, 24, 26. You might see halves. So that would be like 2.5, 6, and 6.5. Anything that holds the same proportion. Over here we have 7, 24, and 25. And down here, the least common one, it gets less common the bigger you get, 9, 40, and 41. That's not even one I really have memorized. I have the first 3 sets memorized. I usually forget about 9, 40, and 41. There's infinite many triples, but these are the ones that people usually use. So we might see that come up in our problems today. What we are going to start with is, do the following lengths form a right triangle? So this is a yes or no question, but you have to use the Pythagorean theorem or a set of triples to show the answer. So I'm going to show number 2. We don't know, it's not labeled where the right angle is, but I know that the longest side has to be side C. The other 2 can be A or B, it doesn't matter. So the way that I would set this problem up is I would say A squared plus B squared equals C squared. I would substitute my numbers in. 5 squared plus 12 squared equals 13 squared. And then I would actually solve this to see if the two sides equal each other. So this is going to be 25 plus 144. That equals 169. And yep, that's what 13 squared is. So the answer would be yes. If the Pythagorean theorem works, that means it does form a right triangle. If we had gotten, instead of 169, if we had gotten like 175, that answer would be no, because the two sides are not equal. The Pythagorean theorem does not work. Now, some of you guys, because you guys are smart, probably noticed that this was on our triples list a minute ago. A 5, 12, 13 triangle. So you did not even have to show any of this work. You could have just said yes, because we know it's a triple. It's a common triple. So we can just accept that yes is the answer without any work. 4. Well, I know that 5 has to be C, and I know that 3 and 4 have to be A and B, but it doesn't matter which is which. Do you recognize the triple? It's another triple. Yes. And lastly, let's take a look at 6. Now these are decimals, so they can't be a triple. It's not how it's done, so we have to show work. They tell us which one is A, which one's B, and which one is C, although we would also know that the biggest one has to be C, and it doesn't matter which one's A and which one's B. So A squared plus B squared equals C squared, and I'm checking does 2.1 squared plus 7.2 squared really equal 7.5 squared? So I want to pull up my calculator. Hopefully they don't give me an ad. I feel like I'm going to get an ad though. Oh, okay, they're being nice today. 2.1 squared is 4.41. 7.2 squared is 51.84. 7.5 squared is 56.25. Let's see, does this really equal 56.25? 4.41 plus 51.84. It does. So all of our answers have been yes in this section. Yes, they form a right triangle. If the Pythagorean theorem works, that means that it does form a right triangle. So make sure you're answering yes or no for those. For these next types of problems, they'll give you two of the sides and you have to find the missing side length. So let's take a look at number 8. I'm going to move this out of the way. Sorry if you could hear my hand creaking on the table while I did that. So the side across from the right angle has to be side C. It doesn't matter if 6 or 3 is your A and B. It doesn't matter. So A squared plus B squared equals C squared. Since they're telling us it's a right angle, we are assuming that the Pythagorean theorem works. So we know that it will be equal because they told us it is a right angle. That's what allows us to use it to solve for the side. So it doesn't matter who's A and who's B. 3 squared plus 6 squared equals our mystery C squared. 9 plus 36 equals C squared. And then 9 plus 36 is 45. That's C squared. It's not a whole number, but that doesn't mean anything. Take the square root of both sides. I need 45 square root. And I get that C is equal to about 6.71. I like to round it to the hundredths. I know it says to round to the 10th, but I always stick with hundredths. And there's no unit here, so that's our answer. That's our third side. All right. So that's how to do these problems. If they give you the hypotenuse, you have to use algebra to solve it. If the hypotenuse is missing, you could solve it just like I showed you right here. The rest of the problems may get a